Assalamualaikum warahmatullahi wabarakatuh. We are from Group 9 and this is our team. Zohaira, Dani Bashira and also Muhammad Shafiq. And this is our table of contents.
Assalamualaikum warahmatullahi wabarakatuh. My name is Amirul Shafiq. Today I want to explain about introduction. So underground cable are commonly used to transmit power or communication signal. When fault occur, it is essential to identify their precise location for efficient and prompt repairs. The employment of specialist procedure and equipment is necessary to detect fault in underground cable in order to determine the problem's location precise. Okay, next I want to talk about three fault types underground cable. So for the first one, open circuit fault. It occur break in the conductor of a cable. So it can be checked by a megger, the tools to detect the fault. The three conductors of the three core cable at the far end are shorted and earth. Resistance between each conductor and earth measured by a megger. So if it's not broken, the megger indicates zero resistance in the circuit. So if broken, the megger indicate infinite resistance in circuit. So for the second one is short circuit fault. When two conductors of a multi-core cable come in electrical contact with each other because of the insulation failure, so it is called a short circuit fault. Then two terminal of the megger are connected to any two conductor by using megger. So for the zero reading at the megger, short circuit fault indicated. Okay, for the last one is earth fault, which is the third one. When the conductor of a cable comes in contact with earth, okay, to identify one terminal of the megger is connected to the conductor and the other terminal connected to earth. So zero reading megger, the conductor is earth. The same procedure is repeated for other conductor of the cable. Okay, next I want to talk about difficulty to locate exact fault. For the first one is limited accessibility. Underneath layers of dirt, concrete or other material, underground cables are frequently buried, rendering them unreachable for direct visual inspection. It is difficult to physically locate the problem due to this accessibility issue. So second one is cable complexity. The presence of multiple cables and branching connection can make it difficult to determine the specific cable and fault location. The third one is environmental interference. Noise and electromagnetic interference can be an example. Can obscure or distort signal, making it difficult to differentiate between the fault signal and background noise. So for the last one is signal attenuation. It might be difficult to identify and precisely pinpoint defects due to signal attenuation, particularly for low intensity or high resistance failures.
Okay, so here we go to the popular method, Valley loop test method. Valley loop test is a test that can locate the earth fault or short circuit fault in the underground cable. Valley loop test is a technique for determining the insulation resistance of a cable. The, the test works by applying a direct current voltage between the two ends of the cable and measuring the resulting current flow. The voltage and the current are used to compute the insulating resistor. The Valley loop test require the use of specialized equipment known as a Valley loop tester, which normally consists of a calibrated resistance box, a galvanometer, and a battery or other DC voltage source. So this figure below show the Valley loop test for short circuit and Valley loop test for earth fault. Next, principle of the Valley loop test method. The principle of the Valley loop test is based on Ohm's law. The test is performed by connecting the cable to be tested to a circuit that includes four resistors and a battery arranged in a Wheatstone bridge configuration. The cable is first disconnected from the power source and all other equipment. Then, two conductors of the cable are connected to the two fixed resistors in the Wire loop circuit. The other two resistors in the circuit are connected in series with a variable resistor and a galvanometer. The variable resistor is adjusted until the current flowing through the galvanometer is zero, indicating that the bridge circuit is balanced. The resistance of the variable resistor is then measured, and the insulation resistance of the cable can be calculated using the formula insulation resistance equal to resistance of variable resistor over resistance of fixed resistor, where X is the value of the resistance of the cable insulation. This is the advantage of the Wire loop test. First, the Wire loop test is a simple test that may be done with a minimal set of tools that includes a resistance box, a DC voltage source, and a galvanometer. Second, the Wire loop test equipment is relatively affordable, making it a cost-effective choice for assessing insulating resistance. Third, it can be used to measure insulation resistance in a variety of cable, such as low and medium voltage cable. Fourth, it can be calibrated to provide accurate measurement. This is the advantage of the Wire loop test. First, it may be insensitive to small insulation flows, especially in high voltage equipment. Second, it can take a long time, especially if numerous tests are required to precisely estimate the insulating resistance of a underground cable. Third, it is not appropriate for assessing the insulation resistance of all cable, especially high voltage cable. Fourth, it requires the use of high voltage DC source, which can be dangerous if not utilized correctly. Suitable protective equipment must be employed to ensure that the test is carried out safely.
Next, we move to other methods. Our group got voltage decay methods. Okay, this method requires a surge couple a high voltage DC test and the analyze. Okay, the analyzer acts as a storage oscilloscope, capturing and displaying reflection from the fault caused by the flashover of voltage at the fault. Okay, the analyzer is operates passively and doesn't send out pulses like TDR methods. And the decay methods is used to locate faults on transmission class cables that require breakdown voltage higher than those provided by typical surge generators. Okay, to the breakdown fault and capture the voltage transient, a DC dielectric test set with an output capability of at least 160 kilovolt may be required, and appropriately rated surge coupler and analyzer are necessary to capture the voltage transient. Okay. Next, the decay methods is used to locate fault. As we know, the decay method is used to locate faults underground cable. Okay, it requires a VLF or DC source with higher voltage output, as in the figure. Besides, the method also based on voltage decoupling by a capacitive voltage divider. The faulted cable is charged by applying high voltage VLF, or we can say that DC, up to the breakdown voltage. And a transient wave is created once breakdown is achieved, which travels between the cable fault and the high voltage source. And we can see that in the figure besides. Okay. The transient wave is recorded by a capacitively coupled TDR, and the recorded period of oscillation is equal to default distance. So the decay method is based on transient voltage wave that is continuously recorded by the capacitive coupler. So to detect where is it the fault in the cable, we need to charge the cable with negative voltage, and the flash over at the cable fault creates a positive discharge transient wave that travel towards the near end of the cable. And the high voltage source, the pulse is reflected without a polarity change. Since the pulse travel back to the cable fault, the pulse is reflected and the polarity is changed. So this process is repeated until the pulse dampens and loses energy. Okay, for advantage and disadvantage of voltage decay methods. First, non-destructive. The voltage decay method is non-destructive technique, meaning that it does not require excavation or damage to the cables being located. Sorry. Second, cost effective. Compared to the other cable location methods, the voltage decay method is relatively inexpensive and requires minimal equipment. So it's not so costly and not so low. And third, easy to use. The method is relatively straightforward, can be used by personnel with basic training, and also accurate. The voltage decay method can provide accurate result when used correctly, especially in cases where the cable is not heavily loaded. Okay, for disadvantage, first, limited range. The voltage decay method has a limited range, typically up to a few hundred meters, which may not be sufficient in some cases. Second, ambient noise. The voltage decay method is susceptible to ambient noise, which can interfere with the measurements and reduce the accuracy of the results. Okay, third, high resistance cable. The method may not effective for locating high resistance cables, such as those made of certain material or with certain construction. Okay, 4. Requires access to cable ends. The voltage decay method requires access to both ends of the cable being located, which may not always be possible in certain situations. Okay, that's all.
Okay, for the conclusion, we can conclude that accurate repairs and the continuous operation of electrical and communication network depend on pinpointing the exact location of underground cable faults. There are other fault types that can happen, such as open circuit fault, short circuit fault, and earth fault, which involve a complete stoppage of current or signal passage. Each of the popular method has particular benefits, and the one chosen depends on the features of the cable system and the fault type that has occurred. As continuing advance continue to improve the accuracy and effectiveness of fault detection and location, it is important for professionals to be informed about the most recent development in fault locating technology.